Okay, here we go. On your note card. These are the first definitions you want to put on your note card.
We write them on paper first.
I have given you guys several options to use. If you don't want to use speed, you want to use any of the other ones, you may. You may use theta, alpha, gamma, beta, phi. I don't care.
What if we just use you like in the book?
No. How many different ways do I say I don't care? In addition to this on your note card, you may want to also add sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I would add these also. I gave you a note card without lines on it so that you could write it any manner that you wanted to and it not be affected by the lines. Now, you already know these, okay? But sometimes in the near future, what we're going to be doing is we're going to be doing a lot of substitution. And with that substitution, you're going to be like having that dumb look on your face. You're like, I'm so lost, I don't know which ones to use. So it's really, really helpful to have this in front of you so whenever you have that brain fart and you hit that brick wall and you can't get around it, that you can suddenly break through it whenever you see it on the paper. Do we all understand what I'm saying here? So sine of phi is 1 over the cosecant of phi. If the cosecant of phi is going to be 1 over the sine of phi. The reciprocals of each other. Cosine is 1 over secant, secant is 1 over cosine. Tangent is 1 over cotangent, cotangent is 1 over tangent. And then the very special one at the bottom is going to be the tangent is sine over cosine, which means the cotangent is cosine over sine. These are your 6 trig definitions being used in each other. Then we have our triangle definitions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is going to be opposite over adjacent. If you know those 3, then you can get the other remaining 3 trig functions, cosecant, secant, and cotangent. Now, if you do not want to write this on your index card right now, write it on paper. Do it later. In fact, I would like you to do that. That way we can save on some time and we can get started on your homework tonight together so you have a clue what you're doing. If we spend all of our time trying to write small, you guys are not going to have a clue what you're doing. Now, the next one. I cannot stress to you enough how important this is. These 3 trigonometric identities are going to be your milk for everything that you normally do for your breakfast, right? This is very, very important. Everybody likes their milk for breakfast. Most people do, unless you're lactose intolerant. Sine squared plus cosine squared is equal to 1. It is the most important trig identity that you will ever use. Sine squared plus cosine squared is equal to 1. The next one is 1 plus tangent squared is equal to secant squared. Do the same concept. Pythagorean theorem is going to be using the 3, 4, 5 triangles together. Pythagorean identities and trig identities is the same concept. And the 1 plus the cotangent squared of theta is equal to the cosecant squared of theta. Now I want to make this extremely clear to you people. As soon as you've written down sine squared plus cosine squared is equal to 1, you immediately have 4 more with that trig identity. Let me show you why. I'll flip it back, so please give me a moment. Don't yell at me. Now, if I give you sine squared of theta plus the cosine squared of theta is equal to 1, let's say I wanted to solve that thing for sine squared. What would you do? I wanted to solve for sine squared. You subtract the cosine squared. So what you're telling me is that sine squared is equal to 1 minus cosine squared. Would you have to write that one down if you already know that sine squared plus cosine squared is equal to 1? Could I solve that for cosine squared? What would cosine squared be?
1 minus sine squared.
1 minus sine squared. So that's another one I have in there. Could I then solve it for just sine rather than sine squared? How would I solve for sine? Take the square root of it. How would I solve for just cosine? Take the square root of it. So do you see that actually, when I have one trigonometry, I actually have 5 trigonometries?
You do the whole problem square root.
Because if I want to take the square root of sine, I have to take the square root of both sides. Okay? So with the concept of sine squared plus cosine squared is equal to 1, I not only have 1, but I have 5 trigonometries there. Which means if I go back to this one right here, I don't just have 1 trigonometry or 3 trigonometries. How many trigonometries do I have? I have 15 trigonometries. Do we understand that? I actually have 15 trigonometries. Because from 1 trigonometry, you can get 4 more. Do we all understand that? Do I expect you to memorize 15 trigonometries? No, I expect you to memorize those 3 trigonometries. Because from those 3, you can do everything else you need. Do we understand that, yes or no? Are we good? Okay. Now, the next ones are called cofunction identities. Cofunction identities are actually at the bottom of your page, and you might want to note this so that you know it if you ever lose your notes or don't have them. Your trig identities, your cofunction identities, are on the bottom of page 269. They do not say cofunction identities, but they are there. The sine of theta is equal to cosine of 90 minus theta. The cosine of theta is equal to sine of 90 minus theta. Tangent of theta is cotangent of 90 minus theta. And you can read the rest of them and copy this down. Same concept. Again, they're just cofunction identities. And truly, you never really know when you're going to need them. So it's kind of like, 90. What's 90? 90 is pi over 2, right? So if I have it in radian form, it means pi over 2 minus theta. Pi over 2 minus theta. Yes? Yes, the book has it just as pi over 2. However, in page 269, they don't have it as pi over 2. They have it as 90. You ready? Okay, now, you're going to be mad at me today.
Oh,
You are. I would like you to get your books open to section 4-3, the homework section of it. The homework section of 4-3, which is page what? 274. Page 274. Page 274 and 275. Now, I taught you yesterday, or last week, I talked to you about the triangles, right? Given any triangle, I'm able to find my sine, cosine, and tangent values to the right triangle given 2 of the sides, correct? I can use Pythagorean theorem to find the third side. Is that true or false statement? That's a true statement, right? Now, the textbook, it would not be any fun to introduce the trig identities and not actually use them, right? So if you look at tonight's instructions on page 275, it says for problems 27 to 32, it says use the given function values and the trigonometric identities to find the indicated trigonometric function. They want you to use your trig identities, folks. Your trig identities are, technically speaking, what I just showed you in these last 3 pages here. These are your trig identities. Okay, this is what you have at your disposal. So if we are talking about using that, let's first talk about an example here. theta is an acute angle. If it's an acute angle, how big is it? Smaller than 90, which means what quadrant does it have to lie in if it's smaller than 90? It has to lie in quadrant 1. Now you're going to see me talk about this all period long. In quad 1, it's plus plus. In quad 2, it's minus plus. In quad 3, it's minus minus. In quad 4, it's plus minus. You're going to hear me talk about that all the time because they're going to give you a function value, a meaning singular. In this case, they're going to say such that the sine of theta is equal to 0.6. And they're going to disguise this stuff as to be in decimal form so that your brain can't think easily and look at it on the unit circle. Do you understand that? Now, if I am at an acute angle, my angle has to be less than 90 degrees, which means I have to be in quadrant 1. More importantly, what I want your brain to be able to get out of this is whenever it says the sine of theta is going to be 0.6, it's telling you that it's a positive sign. Well, what quadrants is my sine value positive in? What two quadrants is my sine value positive in? That means it cannot be quadrant 3 and 4. That means it can only be quadrant 1 or quadrant 2. Well, it knocks out quadrant 2 immediately whenever it says that it is an angle less than 90. Do you all understand that? Okay? So you might think that acute angle being less than 90 there is an irrelevant concept, but it is actually very important. That acute angle tells you something. More importantly, it tells you what quadrant you're in, because sine is positive in quad 1 and 2. Now, I need to find cosine and tangent. I am given that the sine is going to be equal to 0.6. I can do this by a triangle, and more importantly, let's show that real fast so that you can see that. If I draw my triangle here, I have 0.6. How do I make that into a fraction? That's 6/10, right? What's 6/10 reduced down to? That reduces down to 3/5. This is going to be the sine. Okay, if that's the sine, well, I'm going to put my angle right here. Sine is going to be opposite over hypotenuse. What does this last side have to be? 4, because it's a special 3, 4, 5 triangle. Can I get the cosine and the tangent values out of there ASAP? Yes, what's my cosine value? Adjacent, which is 4 over hypotenuse, which is 5. What's my tangent value? Opposite, which is 3 over adjacent, which is 4. I did that very, very, very fast. Did we not? Okay? The book doesn't want you to do anything. The book wants you to use the information that you're given. Okay? So the information that we're given is going to be our trigonometries. So if you're given sine, our trigonometries right here, which trigonometry would you use? The first one. So if we use the first one, we're going to know that sine squared of theta plus the cosine squared of theta is equal to 1. And what do I know? What do I know? What was the only thing given to me? Sine is going to be 0.6, and I need to square that. So what is 0.6 times 0.6? What's 6 times 6, folks? What's 6 times 6? 36, but it's going to be 0.36. How do I solve this thing for cosine squared? Subtract 36 cents from both sides. If I have $1 and I subtract 36 cents, how much money do I have left over? 64 cents. Now how do I get rid of that squared? Take the square root of it. So anytime you take the square root, you automatically have to add plus or minus to it. The square root of 60.64 is going to be 0.8. Do you understand that? Why do I have to have positive and negative there? Because if you take the square root of 25, it can be 5 times 5, or it can be negative 5 times negative 5, right?
Yeah, why is it so squared?
Because I forgot to erase the square. Sorry. Do we all understand that? When you have this, you have to add the plus and minus. I want everybody to understand that. Now, that plus and minus is very important because that tells me I can have cosine either being positive or I can have my cosine being negative. Then I have to think back what quadrant I'm on. What quadrant am I allowed to be in? I'm only allowed to be in the first quadrant. Since I'm in quad 1, that means it's the plus plus quadrant. Can it be negative? No. Cosine must be positive. Now, what is 0.8? Just so that we're aware, 8 over 10 is going to give you the 4/5. Is that what we talked about earlier? Now, I have a lot more work this time, but we understand how to use the trigonometry appropriately. That's my cosine value. Now, how do I find my tangent value? Well, I know tangent is going to be the sine of theta over the cosine of theta. Correct? Well, my sine was going to be 0.6. My cosine is 0.8 to give me the lovely little 3/4, so 0.75. Now, half of you did not write that down. Half of you in there just looked at me while I did that entire problem. That is exactly like your homework tonight. And if I don't see that work, you're not getting any credit. If I see triangles on here and I don't see this, you're not getting credit.
Wait, do you want to answer decimal point?
Either or. Okay. The next thing that the directions ask you to do. If you go to the next set of instructions, which is going to be 33 through 36, it says use trigonometric identities to transform one side of the equation into the other side. In other words, I need to change the cosine of theta times secant of theta is equal to 1, and I need to work only on the left-hand side. Change left side only. So, I need to use the trig functions that we wrote down at the very beginning of this period, and I need to transform that left-hand side into a 1 by using those identities. So what do I know about cosine? That is the simplest I can make it. Sine and cosine are the simplest forms that you can possibly make. Do we understand that? So the cosine of theta has to hang out. Now, can I make secant equal something else? That's another way to rewrite secant. Can't hear you. 1 over the cosine, very good. So secant is going to be 1 over the cosine of theta. Now, how are these two things attached? By multiplication. So since they're attached by multiplication, I can cancel those out, and I'm left with 1 is equal to 1. Is that what I wanted? Is that what I wanted? Yes. 33 through 40. Now, the next one. What's your gut instinct telling you to do with this one? We have two binomials multiplied together. Your gut's telling you to FOIL. Now, what do you notice about those two binomials? Think imaginary numbers. What were they called? They're opposites. They're conjugates, meaning they have exactly the same thing on the inside except for what's different. The middle term is what's different. So whenever I FOIL two conjugates together, what happens every time? What cancels? The inner and outer terms cancel. So since inner and outer terms are going to cancel, I only have to do first secant squared of theta, and last minus tangent squared of theta is equal to 1. Now I'm still only working on the left-hand side. I need to go back to what I know. Well, what do I know? I know this right here. Which one of those trigonometries do you think I should use? The second one. The second one is exactly which one I'm going to use. So every place that you see secant squared, what am I going to put in place of it? Every place I see a secant squared, what am I going to put in place of it? You just told me which one I need to use. You told me I need to use 1 plus tangent squared is equal to secant squared. I feel like you're talking in Chinese. Now that we've FOILed, and I've done inner and outer, notice they cancel. We talked about using the trig identity. The 3 trig identities are sine squared plus cosine squared equals 1, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared is equal to cosecant squared. You said to use the middle identity. What am I going to put in for what?
You can do everything right.
No.
Oh,
I cannot touch the right-hand side.
wouldn't 1 plus tangent squared, wherever you plug it in.
Secant squared is 1 plus the tangent squared. 1 plus tangent squared is secant squared. It's simple substitution. Every place you see a secant squared, you can plug in the rest of the identity, which is 1 plus tangent squared. Now, what do you notice about the tangent squares? They cancel out and have 1 is equal to 1. Is that what I wanted? Yes. Do we understand that? You got to make the left-hand side equal to the right-hand side by manipulating it in any possible way that you can. This is number 32 out of tonight's homework tonight. Now again, you can put this into a triangle, but am I going to give you credit for it? No, you can use your logic skills with the triangle to check your answers, but I expect you to use your trig identities to get the answer. Do we understand that? So, they say you are given the tangent of beta is equal to 5. They want you to find the 4 remaining things. A is the cotangent of beta. What's the cotangent of beta? If I know tangent, what do I automatically know? Cotangent, which is going to be the opposite, meaning what? The reciprocal. So this is actually 1/5. So if I know tangent and cotangent, I need to now find my cosine. So what trig function are you going to use to find cosine? When the only thing you know is tangent. So what are my trig identities I need to be thinking about? I only know tangent. So what am I going to use? The middle one. I only know tangent, so I have to use the middle one. So 1 plus the tangent squared of beta is equal to the secant squared of beta. What do I plug in for tangent? 5, so that's going to be 5 squared is equal to the secant squared of beta. Why am I doing that? Because tangent is 5. Well, what's 5 squared? 25. Well, what's 25 plus 1? 26. That's equal to the secant squared. Is that what I want? I want secant. So how do I find secant? Take the square root of both sides. So that's plus or minus the square root of 26 is equal to the secant of beta. That gives me plus or minus. Now that's an issue. I don't know which one I want. Well, think about it. I know that tangent, in quad 1 we have plus plus. In quad 2 we have minus plus. In quad 3 we have minus minus. In quad 4 we have plus minus. What is tangent? Sine over what? Cosine. So in quadrant 1, my tangent is positive. In quadrant 2, what's my tangent going to be? It's going to be negative. In quadrant 3, what's my cosine? Or what's my tangent? Positive. And in quadrant 4, what's my tangent? Negative. In order for my tangent to be positive, I am in either quad 1 or quad 3. Do we understand that? Secant is the reciprocal of what value? So you're telling me that this is going to be plus or minus 1 over the cotangent over square root of 26 is equal to my cosine. That's what you just told me, right? That cosine is the reciprocal of secant. How do I know if it's positive or negative? Well, in quadrant 1, my cosine is positive. In quadrant 3, my cosine is negative. So could it be both outcomes? Yes. Which means all I have to do here is rationalize this to give me plus or minus the square root of 26 over 26. So there is my cosine of beta. Now, guys, we've done this many times. We've done this many times. I do not have to do this every time to rationalize, right? You need to be able to go there. Okay, Okay, letter C. Letter C says to do the tangent of 90 minus theta. Well, what does that look like out of your lovely little indemnities that I gave you? It's going to be a cofunction. Well, what is the tangent of 90 minus theta equal to? The cotangent. Did we already find the cotangent? Did we already find the cotangent? Yes, we already did. Which means all I have to write down now is that this is equal to the cotangent of theta, which gives, or beta, which gives me 1/5. Can we see that? And the last one's going to be letter D. Letter D is going to be the cosecant of beta. I didn't mean to have beta there. Now, how do I find the cosecant of beta? Well, I either need the sine or I need the cosecant. How do I find one of those two? How do I find it? I can use the last trig function. The last trig function is going to be 1 plus the cotangent squared of beta is equal to the cosecant squared of beta. Correct? So what's the cotangent squared? It's 1/5. So that's going to give you 1 plus 1 over 25. Right? What's the 1 turn into? 25 over 25 plus 1 over 25. That's going to give me 26 over 25. Now what do I do? Take the square root. I'm going to take the square root of the top and the bottom. That's plus or minus the square root of 26 over 5 is equal to my cosecant of beta. So essentially, haven't I found all 6 trig functions now? If I needed to, all I have left to do is my sine, right? Number 40. Number 40 says use the trigonometric identities to transform one side of the equation into the other. So which one do I need to work from? Back. Matt, are you copying? What's up? Because I gotta take the square root to get rid of the square here. No, because what's the square root of 25? 5, that's why there's a 5 there.
Yeah, but you have to take the square root of 25 multiplied by
Because it comes out as an even number. I don't have a radical in the denominator anymore, so I don't have to rationalize it. You only rationalize whenever you have a radical in the denominator. I do. What is the square root of 25? It's 5. The radical is no longer there. Right? I have a radical, but it's in the numerator. I don't care if it's in the numerator. I don't want it to be in the denominator. Okay, thank you. If we're doing number 40 here, you're going to tear this thing apart. Tangent of theta over the tangent of theta plus the cotangent of theta over the tangent of theta. Well, what's the tangent of theta over the tangent of theta? 1. Well, this is interesting. This is going to be the cotangent of theta times 1 over the tangent of theta. Right? Can I pull that apart? Anybody tell me what 1 over tangent is? Cotangent. So I have the cotangent of theta times the cotangent of theta. Well, how many cotangent of thetas do I have? 2. And what is 1 plus the cotangent squared of theta? Cosecant. Is that what I wanted it to be? Yep. Matt, what did I do here? I tore the fractions apart and made them into two fractions. Tangent of tangent is 1. I tore the cotangent over the tangent apart and made it cotangent times 1 over tangent. And then I said 1 over tangent is actually cotangent. And then I said that cotangent times cotangent is going to be cotangent squared. And this is the deputy. Okay, guys. See you tomorrow.